Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening.
Good evening.
Good evening. Good evening. I've shared my screen, children. Is it visible?
Yes, ma'am.
Yes, ma'am.
All right, children. Let's work some extra problems from this chapter, areas related to circles. Please write down the first question. Please write down the first question. Let's try it together. Two circles touch externally. They touch externally. That means they have only one point in common. They don't intersect at 2 points. They just touch externally. That means there's only one point common to the circles. The sum of their areas is 130 pi square centimeter square. And the distance between their centers is 14 centimeters. Find the radii of the circles. We need to find the radius of each of the circle. Two circles, different radii, one small, one big. Draw them so that they touch externally. Call the radius of one circle R1, the other one R2, or you can use small r and capital R. Small r for the small circle, big R for the big circle. I want you to try first, children. I'll show the answer. We'll discuss the answer. I'll show you the steps, but try it yourself first. Draw two circles so that they touch externally. That's the first thing. Let R1 and R2 be their radius, or you can say small r, capital R. Sum of their radius is given to you. So use this information and create an equation. The distance between their centers is given to you. Use this information also. Yeah. If you have made the figure, please take a picture and put it on WhatsApp for me. Yes, I got it from Srinivasan. Correct. Good, Srinivasan. What is 2 pi r plus 2 pi r, Srinivasan?
Ma'am, I was writing, ma'am. I
Okay.
said before, right?
No, but the sum of their areas.
130 pi.
No, you have written 2.
Sorry,
Okay.
ma'am. I written wrong.
Yeah. Your figure is right. Very good. Shivani has shared the picture. Yes, Shivani, your picture is correct, but make sure that the circles are of different sizes, Shivani.
Okay, ma'am.
Yeah, one small, one big. Yeah, because nothing is mentioned, no? Otherwise, there's nothing to work. If there are two congruent circles and the distance between their centers is 14 centimeters, then each radius will be 7 centimeters. There's nothing to work there. Yes, I want more pictures on WhatsApp. Only 2 of them, Shivani, Srinivasan, then others. Correct, Reshmika? Correct.
Okay, ma'am.
All right, let's see the answer. See here. You can do it like this. 2 circles, they touch each other. So they touch each other at M. They touch each other. They don't intersect at 2 different points. They just touch each other externally, not internally, externally, outside. They touch at M. All right. And let OM be the radius of the first circle, OM be the radius of the first circle, R1, and O dash M, radius of the second circle, R2. O and O dash being the centers of the 2 circles. So now sum of their radius is 130 pi. That means the radius of, the area of this circle, pi R1 square, plus the area of this circle, pi R2 square. The sum, meaning you'll have to add, the sum of their areas is equal to, when you add the areas of the 2 circles, the answer is 130 pi. So take out pi common, and we have this, pi on either side gets cancelled. And we have R1 square plus R2 square is equal to 130. Next, it's given that the distance between their centers. Distance between their centers. Just look at this figure. What is the distance between their centers? O dash. O dash is the distance between their centers, and that's given to be 14 centimeters. The distance between their centers, O dash, it's given it's 14. It's given it is 14. That means what? OM plus O dash M is equal to 14, which again means R1 plus R2 is equal to 14. R1 plus R2 is equal to 14. Now we are going to solve the 2 equations by the substitution method. So you can write R1 is equal to 14 minus R2, or you can write R2 is equal to 14 minus R1, anything. So we're going to now substitute 2 in 1. We have called this 1 and 2. Here result 1 and result 2. Now substitute 2 in 1. Substitute the second result in the first one. So in place of R1, we are going to say 14 minus R2 here. In place of R1, 14 minus R2. Here, instead of R1, we are going to say 14 minus R2. R1 square it is. So 14 minus R2 the whole square. Plus R2 square is equal to 130. So this will give you a quadratic equation in R2. This will give you a quadratic equation in R2. Solve and find R2. Once you find R2, substitute here. Supposing R2 is 7, say 10. R2 is 10. So R1 will be 14 minus 10, 4 centimeters, like that. Please complete it.
Ma'am, here the distance 14 centimeters, the line you have drawn, right?
Yeah.
Fine.
Yeah, you can complete this yourself. See the answer in the next page. So on solving, we get R2 is 3 or R2 is 11. On solving, R2 is 3 or R2 is 11. So when R2 is 3, R1 is 14 minus 3, 11 centimeters. When R2 is 11, R1 is 14 minus 11, 3 centimeters. So the radii of the two circles are 11 centimeters and 3 centimeters, or 3 centimeters and 11 centimeters. Yes, you should be able to complete that yourself. Moving on to the second one. Write down the question. Complete that. We saw the steps to get the answer. Complete that later. Leave some space if you have not completed. Take the second question. Two circles touch internally. The sum of their radius is 116 pi square centimeter, and the distance between their centers is 6 centimeter. Find the radii of the circles. Yes. So see here, this is how we consider circles that touch each other internally. This is how we consider two circles. This is how we consider two circles that touch each other internally. So here they touch each other internally at M. Internally at M. The circles are touching internally, and the point where they touch is M. So let O be the center of this big circle and O dash be the center of the small circle. Then this is the distance between their centers. This is the distance between their centers. Let O be the center of this big circle. Let O dash be the center of the small circle. and the two circles that touch each other internally, they touch at M. Now the sum of the radius is given. So like this, if R1 and R2 are the radii, pi R1 square plus pi R2 square is equal to 116 pi. Then the distance between their centers is OO dash. OO dash is the distance between their centers, which is given to be 6 centimeters. OO dash is the distance between their centers, which is given to be 6 centimeters. How do you express OO dash? It is OM minus O dash M. OO dash is OM minus O dash M. So it's OM minus O dash M, which is 6. What is OM? OM is the radius of the big circle. And what is O dash M? It's the radius of the small circle. That means R1 minus R2 is equal to 6. R1 minus R2 is equal to 6. OM is the radius of the big circle, R1. O dash M is the radius of the small circle, which is R2. R1 minus R2 is equal to 6. So like the earlier one, we are going to use the substitution method. The procedure is familiar to you. Yes, just get started with the answer. You may complete it later. Leave some space for that. I'm just waiting for you to just take down the steps so that you can complete it later. All right. Yes. Right on the third question. The side of a square is 10 centimeters. The side of a square is 10 centimeters. Find the area of the circumscribed and inscribed circles. Find the area of the circumscribed circle and the inscribed circle. So there's a square. Now, case one is a circle circumscribes the square. A circle circumscribes the square. That means it goes outside the square. Runs through the vertices of the squares on the outside. Inscribed circle. The circle which is drawn inside the circle, touching the four sides of the circle. Sorry, touching these four sides of the square. The circumscribed circle will run outside the square through its vertices. The inscribed circle will lie inside the square, touching the four sides of the square. Write on the question, we'll see the figures. See here. So here a circle circumscribes the square. A circle circumscribes. See here, the circle circumscribes the square. That means the circle runs outside the square through its vertices A, B, C, and D. The square is inscribed in the circle. The square is inscribed in the circle. The circle circumscribes the square in the first case. Here, the circle is inscribed in the square, or the square circumscribes the circle. Just tell that to yourself. I'll repeat it a little later. Just use the words circumscribed, inscribed. You can explain this figure using both the terms, circumscribed and inscribed. You can explain this figure also with both the terms, circumscribed and inscribed. Practice saying that. I'll repeat it a little later. All right. So I was telling that in this figure, the circle circumscribes the square, or the square ABCD is inscribed in the circle. This figure, the square ABCD circumscribes the circle with center O. The circle with center O is inscribed in the square ABCD. All right. So this is how we have the two figures. Now we are given that the side of the square is 10 centimeters. The side of the square is 10 centimeters. So go through the working. This should be easy for you. Draw the figure. I'll show the complete working. In case you have any questions, you can ask me. This is simple for you to understand. Having said that, you can ask me. You have any clarifications, please ask me. I'm just showing up the figures. Scroll down. So here, the side of the square 10 centimeters, you can see it here. And here the side of the square 10 centimeters is also the diameter of the circle. Is also the diameter of the circle. Yeah, I want you to important, simple question, but it's very important. So I want you to complete this working now in the class. Am I audible, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, children. Thank you. All right. Children, I want you to finish this in the class. Please complete this. As you write, please understand what you're writing. Now you're alone there, so you can just tell it out, read it aloud, tell it to yourself and write. Even in a classroom, you cannot do that because there'll be friends beside you, so you'll be conscious. Now you're free to study the way you want.
Ma'am, can you scroll up?
Sure. So here in this case, with the help of the side of the square, you can find the diagonal. You can find the diagonal of, you can find the diameter of the circle with the help of the side, because the diagonal of the square is also the diameter of the circle. When you connect AC, AC is the diagonal of the square, but it is the diameter for the circle. Now the question is, how do we know that this AC will pass through O and it is the diameter? That's because we have angle D is 90 degrees. Angle D is 90 degrees, and we know that angle in a semicircle is a right angle. Hence AC must be the diameter and O should lie on AC. I repeat, since ABCD is a square, ABCD is a square, ABCD is a square, so every corner is a right angle. Now AC, now the question is, does the center O of the circle lie on AC, lie on the diagonal AC? And the answer is yes, because by the theorem, angle in a semicircle is a right angle. If this angle is 90 degrees, then AC should be the diameter. Then AC should be the diameter of the circle, which means the center lies on AC. So AC is of course the diagonal of the square. AC is of course the diagonal of the square and also the diameter of the circle. So you can use Pythagoras theorem and find AC. Here I've used the formula directly. The diagonal is given by the formula root 2a. You can also use Pythagoras theorem. DC is 10, so AD is also 10, and you can find AC using Pythagoras theorem, root of 200, which is 10 root 2. So since that's a diagonal is 10 root 2, but that's the diameter for the circle. Diagonal for the square, but diameter for the circle. So the radius is half of it, which is 5 root 2. In this case, the side, again, I think it's the same question. Yeah. So yeah, for the circumscribed one. What was given? The circle circumscribes the square. Okay. So here the circle is inscribed in the square. The side is given to be 10 centimeters. Now the side 10 centimeters is the diameter. The side 10 centimeters of the square is the diameter of the what?
Circle, ma'am.
Circle. So the radius is 5 centimeters. Radius is 5 centimeters. And in both the cases, you'll have to find the area of the circle. To find the area of the circle, you need to find the radius. So having found the radius, pi r square will give us the area. Pi r square will give us the area.
Ma'am, 1 minute, can you show the first one, ma'am?
First one meaning child, which one? This one?
The two circles touch externally, that one means.
Oh, okay, sure. Yeah.
Thank you, ma'am.
Yeah. Take on the fourth question, children. The fourth question. You'll have a test based on these portions on Wednesday. Wednesday, the test will be available from 9 in the morning. Nothing. You don't need to prepare anything much. Just the basics. If you
Ma'am,
want.
what
Areas.
about the
What about the?
pair of linear equation word problem test, ma'am?
Yeah. I'll let you know. I
Okay.
want to take up a discussion in the class and then schedule the test, because I need to make sure that you've all watched the videos and understood the content.
Fine. Okay.
So sometime this week we'll take up a discussion session on word problems, linear equations, and then I'll schedule the test.
Okay, ma'am.
So for Wednesday's test on areas related to circles, no hard preparation required. Seriously, just the basic knowledge. You must know the formulae used in the chapter, and I think what we do today will be important. Whatever we do today will be important for the test on Wednesday. The duration of the test is always a little more than what you actually need. So if I feel that you can, finish the paper in 1 hour 15 minutes, I keep it open for 2 hours. So don't be lazy to work. Don't do it slowly. You should work in your pace. So just because it's for 2 hours, it doesn't mean that you can just work it very slowly. That way, then your speed might reduce also. You work as if you have to submit it the next minute. Don't look at the timer and think, oh, we have 2 hours, so I can work for some, take a snack break and then get back. It's not for that, because you'll have to work it and then select the answers. I'm just giving you about 20 to half an hour extra. So I leave it to you to maintain your pace and complete the exam sooner than the given duration. the area of a circle inscribed, so inside an equilateral triangle is, so this is very important. Whose area is given? Let's read it again. The area of a circle inscribed in an equilateral triangle is 154 square centimeter. So this 154 is the area of the circle or area of the triangle?
Area of the circle.
Area of the circle. So the area of the circle.
An area of circle, ma'am.
Yeah, area of the circle inscribed. The circle, they're telling you where the circle is. The circle is in an equilateral triangle. The area of the circle is 154. So again, in the exam in a hurry, we might misuse this information, misinterpret this information. The area of the circle is 154. Find the perimeter of the triangle. So given some information about the circle, you will have to find something of the triangle. So area of the circle is 154. Find the perimeter of the triangle. Find the perimeter of the triangle, which means you'll have to find the side of the triangle and hence find the perimeter. Yeah, worked it in two ways. Let's see the first method. You first go through the working, children. Please go through the working and then I'll explain. Just have a look.
Ma'am, how do we know that board weights AM in the ratio 2:1?
Yeah, I must tell you that. Yes. Just take it for granted now and continue with the working. Go through the working. I'll tell you that. We were not asked to find the area of the triangle. I think I've just found it by mistake. We were not asked to find the area of the triangle. We were asked only to find the perimeter of the triangle. All right, children. So here you understand the figure. Now, in an equilateral triangle, now we have these line segments, no, coming from the vertices. We have the altitudes. We have the medians. There's also a line segment which is called the angle bisector segment. We'll not talk about that now. All right, now let's just talk about the line segments, altitudes and medians. An altitude is a line segment from the vertex perpendicular to the opposite side. You may write down that. An altitude, we are talking with respect to a triangle. With respect to a triangle. In a triangle, an altitude is a line segment from the vertex perpendicular to the opposite side. An altitude See, I trust all of you writing.
Yes, ma'am.
Yeah. Please write. An altitude is a line segment from the vertex perpendicular to the opposite side. Perpendicular to the opposite side. A median is a line segment. Median is a line segment from the vertex. From the
Please
vertex.
repeat the median.
Median from the beginning, huh?
Yes, ma'am.
Yeah, median is a line segment. Median is a line segment from the vertex to the midpoint of the opposite side. To the midpoint of the opposite side.
Ma'am, it's also perpendicular.
That's what. In the case of an equilateral triangle, altitudes and medians are the same. An altitude is also the median. Now here the altitude AM is also the median. That is AM is perpendicular to BC as well. M is the midpoint of BC. AM in an equilateral triangle, the altitudes and the medians coincide. In an equilateral triangle, the altitudes and the medians coincide. A triangle has 3 altitudes and 3 medians. In an equilateral triangle, the altitudes and the medians coincide. In an equilateral triangle, the altitudes and the medians coincide. So now AM coincide meaning they're not different, it's the same. AM, the 3 medians and the 3 altitudes in an equilateral triangle, they coincide. Okay, so equilateral triangle ABC in circle, center O, AM is the altitude, say altitude. So see, it's a line segment from the vertex perpendicular to the opposite side. So let's say AM is the altitude from A on BC. Altitude will also be the median. In an equilateral triangle, altitude is also the median. So AM, this line segment AM, will also be the median, meaning M will be the midpoint of BC. When it's altitude, it makes 90 degrees with BC. When it's median, M is the midpoint of BC. In an equilateral triangle, this line segment AM will be both the altitude from A and the median from A. Now, the important result is, now I need to define a centroid for you. Please write down. The point of concurrence of the 3 medians in a triangle is called the centroid. Write down. The point of concurrence because intersection means where only 2 lines intersect, where only 2 lines or line segments intersect. So when we're talking about more than 2, we say concurrence. That's the difference. Concurrence, when 2 lines meet, we say the 2 lines intersect. We don't say that the 2 lines are concurrent. When 3 lines or more than 3 lines, they meet, then we say they are concurrent. Okay, so concurrent is similar to the intersection. Just a minute, children. Yeah, children. So I was telling you that, what was I telling you? Centroid. Yeah. The point of concurrence of the three medians in a triangle is called the centroid. The point of concurrence of the three medians of a triangle is called the centroid. Write down that.
Completed.
Can you repeat?
Sure. The point of concurrence of the three medians of a triangle is called the centroid. Shakti, are you there?
Yes, ma'am.
All right. All right, children. So that's what is a centroid. Now see here, you can't see the lines, but then I'll just show you. Now from B, let's just draw the altitude from B. So it'll be like this, right? Altitude from B, like this. The altitude from B will also be the median from B on AC. The altitude from B on AC will also be the median from B on AC. Now this is the vertex C. The altitude from C on what? The altitude from C on the altitude from C on
AB, ma'am.
AB, on AB. The altitude from C on AB will also be the median from C on AB in an equilateral triangle. So if you call this, say CP, if you call it CP will be perpendicular to AB because altitude. CP will be the median to AB, P being the midpoint of AB. Now the medians and the altitudes will go through the same point. You can even make a note of this, write on this. The point of concurrence of the altitudes of a triangle is called the orthocenter. Medians is called centroid. Altitudes is called orthocenter. Write down that. Medians, centroid. Altitudes, orthocenter. Ortho.
When altitudes become the center point of a.
Yes. The incircle, the circle. Yeah, there's a lot of theory here. I will do it one by one. The incircle, the circumcenter, the incenter, the circumcenter, the centroid, and the orthocenter, they coincide in an equilateral triangle.
Ma'am, what is the correct definition of orthocenter, ma'am? If they congruent.
Yeah, I'll tell you. Orthocenter is the point of concurrence. Orthocenter is the point of concurrence of the three altitudes of a triangle. Where they meet, they all meet. See here, now let me draw. Now you can see one altitude AM. Now say another altitude from B, BN, and say CP, AM, BN, and CP. Now in an equilateral triangle, AM, BN, and CP, the altitudes, they'll go through the same point, and that point is called the orthocenter. Again, now in any triangle, see, in every triangle, the altitudes and medians, they are concurrent. They'll go through the same point. But in other triangles, the centroid and the orthocenter will be two different points. But in an equilateral triangle, the point which is a centroid will also be the point of the orthocenter. That's what it is. No, we'll do it one by one. Now we've just started. If we want to understand the last thing, then it becomes difficult. We have so many things in the middle. So let's do it one by one. First, let's understand this. AM altitude. BN. You don't see BN here. Now assume, just see that. BN. Visualize that. BN altitude. CP altitude. Do we understand that? Can you see?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes,
Now,
ma'am.
these three altitudes, children, these three altitudes in every triangle, they'll go through the same point. They'll have one point in common. When you draw BN and CP, they'll all forget this point O, children. Forget this point O. Don't see O. When you draw BN and CP like this, they'll all go through the same point. That's called the point of concurrence. And that point of concurrence is called the orthocenter. Where the altitudes meet is called the orthocenter. Do we understand that?
Yes, ma'am.
Yes, ma'am.
Now visualize them as medians. AM is the median, BN median, CP median. In every triangle, the medians are also concurrent. The medians also will go through the same point. They'll have all the three of them will meet at a point, and that point is called the centroid. So when you draw the three altitudes in a triangle, they'll all pass through the same point, and that point is called the orthocenter. When you draw the three medians in any triangle, when you draw the three medians will go through the same point. That point of concurrence is called the centroid. Altitudes, orthocenter. Altitudes, orthocenter. Median, centroid. Now, in other triangles, this point centroid and the orthocenter, they'll not coincide. There'll be some two different points. But in an equilateral triangle, the position of the orthocenter is the same as the position of the centroid. Because the altitudes and the medians coincide here. The altitudes and the medians, they coincide in an equilateral triangle. So whichever is the orthocenter will also be the centroid. In addition to that, in an equilateral triangle, when you draw its incircle like this, now the center of the incircle is called the incenter. The center of the incircle is called the incenter. And now you know what a circumcircle is. A circle passing through the vertices ABC. If you draw a circle passing through the vertices ABC, that's called the circumcircle. Now the center of the circumcircle is called the circumcenter. Now see, children, we hear stories from elders. I don't know if it's common in this generation, but we know that elders are good at storytelling. So don't we understand when they narrate a story, we listen with a lot of interest, and hence we understand. The same thing applies here. If you're listening to me with interest, you will definitely understand. Here I'm not boasting my teaching skills. I'm boasting about your listening skills. You will understand if you are focused. So there is theory. I'm telling you, I've been talking for some time, but it is easy to understand provided you are following my words carefully, like you listen to a story. A story is so interesting to listen because you are listening with it carefully and you are understanding every part of the narration. Yeah, listen to me carefully. So now this circle is the incircle to the triangle because it lies inside the circle, touching the three sides of the triangle. And the center of every circle has a center. Now the center of the in circle is called the in center. You can also draw a circle passing through the vertices ABC, and that circle will be called the circumcircle. Every circle has a center. So the circle also has a center, and the center of the circle is called the circumcenter. In center for in circle, circumcenter for circumcircle. Now the beautiful thing in an equilateral triangle is that the position of the in center, the position of the circumcenter, the position of the centroid, and the position of the orthocenter coincide. They all is the same point O. If you call this O, the center of the center of the circle, the in center is also the circumcenter, is also the centroid, is also the orthocenter in an equilateral triangle only. We are not done. I have to tell you something more, but I'm just pausing so that you.
Ma'am, I have a doubt.
No, not now, darling. Let me just finish it. No, please. Let me just finish it.
Yes, ma'am.
All right. So we were talking about centroid. So the three medians, median from B, median from C, median from A, they'll all go through the same point, and that point is called the centroid. Altitude from A, altitude from B, altitude from C. They'll also go to the same point. And that point is called the orthocenter. In circle, touching the sides, in center. Circumcircle, going through the vertices, circumcenter. In an equilateral triangle, the in center, the position of the in center is the same as the position of the circumcenter, is the same as the position of the centroid, is the same as the position of the orthocenter. And the centroid lies on the median. The centroid lies on every median, and the centroid divides the median in the ratio 2:1. The centroid lies on the median, and it divides the median in the ratio 2:1. So since O can be looked at as anything, so center of the circle, it's a centroid, it's everything. So AM is the median. We consider the median AM. It is not given. So median AM, O lies on the median, the centroid lies on the median, and it divides the median in the ratio 2:1. 2 parts from the vertex. AO is 2 parts. OM is 1 part. It's not the other way. It's not OM is 2 parts and AO is 1 part. From the vertex to the centroid, 2 parts. From the centroid to the midpoint M, 1 part. Now try to.
Ma'am, can you repeat?
Yeah, sure. I'm just coming back. Sure. I'll just come back. Yeah, now please ask me. Yes, your questions, children.
Ma'am, can you repeat the
No,
ratio, ma'am?
yeah, before that, I think it was Shivani. I'm not sure. Wanted to ask something?
Ma'am, I wanted to ask, ma'am.
Yes, Shivani, tell me.
Ma'am, that you said circum. Ma'am, that only for triangular, ma'am. Outside circle comes circus.
No, even for a square, circumcircle, for a triangle. Okay, for a triangle, you can draw an insert to every triangle, whether it is isosceles, scalene, equilateral, every triangle you can draw an incircle, you can draw a circumcircle. You can draw one circle for every triangle. You can draw a circle touching the sides, passing through the vertices. The triangle which is drawn touching the sides is called the incircle, which passes through the vertices is called the circumcircle.
Thank you.
Yeah. No, I don't think that was your question, Shivani. What was your question?
Ma'am, I asked if only a triangle or a quadrilateral is also possible, ma'am.
Yes, you can, no, but not every, because in the case only a cyclic quadrilateral. For every quadrilateral, you cannot draw a circumcircle and incircle. Now, for a rectangle, just think of a rectangle. You cannot draw incircle to a rectangle, because you can draw a circle inside a rectangle, but that circle will not touch all the four sides. You can draw a circle. You can draw a circle inside a rectangle, but the circle will touch any two opposite sides. You cannot draw a circle in a rectangle touching all the four sides. But in a square, you can draw. In a square, you can draw a circle touching all the four sides, and you can also draw a circle passing through all the vertices. Again, for a rectangle, you cannot draw a circle passing through all the four vertices for a rectangle. Now see the other method, children. Now we have learned cyclic quadrilateral, right? Cyclic quadrilateral. If you can draw a circle, the circle passing through the four vertices of a quadrilateral is called a cyclic quadrilateral. So here we had to answer the perimeter, children. I have found the area extra, but we just have to answer the perimeter. And here you can see the alternate method using trigonometry. Have a look at it and then I'll get back to you. This is using trigonometry. You will have a few questions as you're going through the working. You have a look at it. Ask your questions later. Okay. So here we are given the radius of the in circle, the radius of the circle, and the question is to find the perimeter of the triangle, perimeter of the equilateral triangle. So see the alternate method. So since we are given, oh, we were not given the radius, is it? I forgot the question. I think we were given the area. All right. We are given the area of the in circle. We are given the area of the in circle. So area pi r square is 154. So we find the radius is 7 centimeters. So see here. Take up this construction like this. Draw OM perpendicular to BC and join OB. Join OB. OM is perpendicular to BC. Draw OM perpendicular to BC. And it will be now this point M. I told you in the last class that the radius and the tangent at the point of contact are perpendicular to each other. BC acts as a tangent to the in circle. BC acts as a tangent. In fact, all the three sides of the triangle are tangents to the circle. AB is a tangent to the circle at this point. AC is a tangent to the circle at this point. BC is a tangent to the circle at the point M. Now, when you join O and M, OM will be perpendicular to BC by the theorem. OM will be perpendicular to BC by the theorem. If M is the point of contact, BC is a tangent to the circle. If M is the point of contact, if you mark the point of contact as M, when you join OM is the radius. OM is the radius, and OM is the radius that connects the center and the point of contact. So this radius and the tangent at the point of contact are perpendicular to each other. That's what you see here. Radius perpendicular to tangent. Radius perpendicular to tangent by the theorem. So with the help of the area, we find the radius. Then we have constructed a right triangle here. We make a right triangle. OM is perpendicular to BC, radius perpendicular to tangent. M is the point of contact. You can treat it like that. M is the point of contact of the tangent. So in this right triangle, we know that the radius is 7 centimeters. We found the radius is 7. And how was this 30 degrees? Because O is the in center. O is the in center. And again, we do not have constructing in circles and circumcircles in our syllabus in CBSE. So now this one, when you join the in center to the vertex, that will be the angular bisector of B. Now you have to take it theoretically because we are not introduced to the construction of incircles and circumcircles. Or maybe if you're in junior classes, if your school was following a different book, maybe you learned it. I don't think it's in the NCERT textbook for standard 6 and 7. Just understand this. This is the in center. O is the in center. O is the in center. When you join O to the vertex B, angle B will be bisected. Angle B is bisected. OB bisects angle B. And angle B is 60 degrees because it's an equilateral triangle. Angle B is 60 degrees. So it's bisected. So this is 30. Similarly, when you join O to A, when you join the in center to the vertex, that will be the angular bisector of A. That will be the angular bisector of A. So 60 degrees, 30, 30. Same thing here. When you join the in center to C, angle C is 60 degrees. OC will be the bisector of angle C. So 30, 30. So see here we want to use trigonometry. So we are somehow getting a right triangle. Now we have a right triangle here, and we have the radius is 7 centimeters, and we found this angle is 30 degrees. So now we are going to connect 30 degrees with OM and BM. You'll have to connect an angle with two sides. Trigonometry works like that. You'll have to connect an angle with two sides. You'll have to connect an acute angle in a right triangle You'll have to connect an acute angle in a right triangle with two sides. So we are connecting this acute angle 30 degrees with the sides OM and BM. With the sides OM and BM. So for 30 degrees, OM is the opposite side and BM is the adjacent side. OB is the hypotenuse. In the right triangle, OB is the hypotenuse. And for this angle 30 degrees, OM is the opposite side, BM is the adjacent side. Opposite, adjacent. So you have to use tan or cot. Tan 30 degrees is equal to opposite OM by adjacent BM. Tan 30 degrees is equal to opposite OM, which is 7, by adjacent BM. The value of tan 30 from the table is 1 by root 3 is equal to 7 by BM. So on cross multiplying, we have BM is equal to 7 root 3. And BC will be equal to twice. Because again, now you will wonder, how do you know that M is the midpoint? You can join OC. You can show that the triangle. You don't have to work all that, but just for you to understand, when you join OC, the two triangles you can prove are congruent to each other. So BM is equal to MC. So BM is equal to MC. When you join OC, these two triangles are congruent. So BM is equal to MC. All right. So now that we found BM, twice BM will be BC, 14 root 3. And now the perimeter. So we found the side. That's why we found BM. Why did we find BM? Because when we find BM, we can double it and find BC. And once you find BC, it's an equilateral triangle. All the sides are equal. So the perimeter is 3 times 14 root 3, which is whatever you see here, 72.66. So equilateral triangle in circle. This is the in center. This is the in center. Join OB. When you join the in center to the vertex, that will be the angular bisector. This angle is 60 degrees. So it's bisected. You have 30 degrees here and 30 here. That's how we get 30 here. And M is the point of contact. M is the point of contact of the tangent BC. When you join the center to the point of contact M, which will be the radius and the tangent at the point of contact are perpendicular to each other. So we have 90 degrees here. Now this is a right triangle. OMB is a right triangle. We have 30 degrees here. This is 7. We found pi r square is 154. So we got 7 here radius. Now with the help of 30 degrees and 7, we are trying to find BM so that we can double and find BC. And that is possible using trigonometry. Tan 30 degrees is equal to opposite OM by adjacent BM. And this value we pull it from the table. On working this, BM is 7 root 3. Double it to get BC, and thrice BC is the perimeter. When it comes to
Ma'am,
yes,
ma'am, I am having doubt in the previous slide.
this one or the next one?
Previous.
This one, huh?
Yes, ma'am.
Yeah, tell me.
This 2:1. This is only for the equilateral triangle, not this ratio.
Very good question. Very good question. No, in every triangle, in every other triangle, the centroid divides the median in the ratio 2:1. Very good question. In every triangle, any triangle, the centroid divides the median in the ratio 2:1.
To find the value of the side of the equilateral triangle, can we use the Pythagoras theorem?
Yes. Tell me. Which method?
No, that only.
Using which method? I don't know. Something you can find something and use Pythagoras theorem, but I don't know. Like.
I found using Pythagoras theorem. As M is the median, I took the MC is equal to half AC. So by that I got 14 root 3.
No, if you read out your steps, I can tell you, or you share the picture on WhatsApp, I can go through and let you know if your steps are correct.
Okay.
Yeah. You can either read out your steps, but I think still better if you share a picture of your working on WhatsApp. I can go through now in the class and tell you if you're right.
Okay.
Yeah. Yes, class. So in any triangle, whether it is a scale into whatever triangle, the median, the centroid divides the median in the ratio 2:1. All right, this is important. Please write down, complete this answer. Please complete this answer, children. Yes.
Ma'am, how did it come? OM is equal to 1/3 into AM?
Yeah, like what I did was OMS, AOS to OMS 2:1, right?
Yes, ma'am.
Yeah, now what is AO now if you call AO as 2x and OM as 1x.
Yes, ma'am. OM is the radius, so.
OM is the radius. OM is the radius. Now see here, what is AO? 1 minute. What is AO plus OM? What is AO plus OM? AM, right?
3x. Yes, ma'am.
AM. AO plus OM. AO plus OM is AM. So AO is 2/3 of AM and OM is 1/3 of AM. From this ratio,
Okay.
From this ratio, AOS to OM. AO is 2 parts out of 3 parts of AM, 2/3 of AM, and OM is 1/3 of AM.
Okay, ma'am. Yes. So OM we substitute that and do 1/1/3 of the entire length.
Yeah. See, this is the full thing. This is the full thing. AM is the full thing. On AM, we have 2 segments, AO and OM. AM is the full thing. On AM, we have AO and OM. AO is 2 parts, OM is 1 part. So AM is 3 parts. AM is 3 parts. AO is 2 out of 3 of AM. AO is equal to 2 out of 3 of AM. So 2/3 of AM, 2/3 into AM. OM is 1/3 of AM. OM is 1/3 of AM.
Understood, ma'am.
Yeah. Children, please complete this answer. Please complete this. See, doubts on these cannot see. This is, we took quite some time to understand this. So please think it over, get your doubts clarified now. It's difficult to take up the same thing in the next class. Complete your answer. Finish working. As you're working, anything comes to your mind which is not clear, get it clarified now. If you worked it in a different way, share the picture. So Shakti, how did you use this ratio 2:1, right, to get AM as 21?
Yes, ma'am.
Okay. That's fine. Yeah. So using this ratio, that's what I wanted to know, because you can use Pythagoras theorem, but straight away you cannot in the first place itself use Pythagoras theorem. That's what I asked you. Yeah. So using this ratio, that's what I understand. Using this ratio 2:1, because OM is 7, AO is 14. So 14 plus 7, 21. I think you found it like that, correct?
Yes, ma'am.
Yeah, that's right. Any questions, children? I'm waiting for you to finish.
Completed.
All right.
Should we write the alternate method also?
Yes, I think it is important. Yes.
Ma'am,
Yes.
is it a formula that root 3 by 2 into the side of the equilateral triangle is the altitude of a triangle?
Correct. Yes. Root 3 by 2 into side. Root 3 by 2 into side. Yes, is the formula to find the altitude of an equilateral triangle. Root 3 by 2 into side is the formula to find the altitude, the length of the altitude of an equilateral triangle given the side. So supposing the side of the triangle says 14 centimeters. If the side of an equilateral triangle is 14 centimeters, the length of its altitude will be root 3 by 2 into side. Root 3 by 2 into 14. So 7 root 3. The length of the altitude will be 7 root 3. Is it over, children? I'm just shuttling between the two pages.
No, no.
No?
Yes, ma'am. Completed, ma'am.
Have you all finished this first method?
Yes, ma'am.
Yes, ma'am.
Please make sure you complete it, children. The second one?
Second one, writing.
Yeah, please write. Please write.
completed.
All right. Let's take down the fifth question. The short and long hands of a clock are 4 centimeters and 6 centimeters long respectively. So a clock has 3 hands, the hour hand, the minute hand, and the seconds hand. A clock has 3 hands. One hand which shows the seconds, the other minutes, and then the hour. Hour hand, minute hand, seconds hand. So here the short and long. The short hand is the hour hand here. The long hand is the minute hand. It's not the seconds hand. Now there you cannot ask me any doubt. That's what it is. So don't look at the clock and now start checking which is short and long. Short hand refers to the hour hand. The long hand refers to the minute hand. All right. So the short and the long hands of a clock are 4 centimeters. So the hour hand is 4 centimeters long. The minute hand is 6 centimeters long. Find the sum of the distances. Distance, not area. Read every word in the question carefully. Find the sum of the distances, not areas, not the area they sweep on the face of the clock. Find the sum of the distances traveled by their tips, the tip of the short hand and the long hand. You should find the distance they travel in 2 days. In 2 days. Yes, you can give it a thought first and then we'll see the answer.
Ma'am, we want to find the perimeter and multiply by 2, ma'am.
No, let's not, stop others from thinking. Yes, you please proceed with your idea. We'll just wait for others to think and then we'll share our answers, share our ideas. Okay. Now let's answer some questions. How many circles? Now we understood, we have taken up clock based sums earlier when we worked the sums from NCERT textbook. So we understood that irrespective of the shape of the clock can be a triangular clock, or the clock can be of any shape. But since the hands are pivoted at the center, they're fixed at the center, the hands will always trace a circle. The hands of the clock will always trace a circle. The clock may be triangular in shape, but that doesn't mean that the hand will trace a triangle. So the hands are fixed to a point in the center, and they move about that. They move about the center. The hands will always be tracing circles. And of course, the short hand will trace, the circles are concentric circles. The short hand will trace a smaller circle. The long hand will trace a bigger circle. Now, how many, answer only this question, children. How many circles will the shorthand? Oh my God, I haven't completed. How many circles will the shorthand trace in one day?
2, ma'am.
2. Okay, how long does a shorthand need to trace a circle?
12 hours.
12 hours.
12 hours. Yeah.
12 hours.
Shorthand, yeah, correct. The shorthand needs 12 hours to describe one circle. To complete a circle, it needs 12 hours. So now say the time is 8 o'clock. It's 8. Visualize when I say 8, see 8 in your mind. Now where is the hour hand? When the clock shows 8, where is the hour hand? It's at 8. Now if the hour hand has to trace a circle, it has to come back to 8. The hour hand, look at the hour hand alone. When the clock shows 8, now say 8 p.m. The clock hand, then when it shows 9 p.m., the hour hand is at 9. When it shows 10 p.m., the hour hand is at 10. 11 p.m., the hour hand is at 11. So when will the hour hand describe one circle? When the clock strikes 8 the next morning. Tomorrow morning, 8 o'clock, the hour hand would have completed one circle. So it takes 12 hours. It takes 12 hours for the shorthand to complete one circle, which means in a day, 24 hours, the shorthand can make only 2 circles. Only 2 circles. What about the hour hand, children? How many circles will the hour hand make? Oh, sorry, the minute hand make in a day? How many circles?
And 24 circles.
How many circles does the long hand, that is the minute hand, make in a day? 24 circles.
24.
24 circles. Because every hour it is making a circle. Every hour. When the clock shows 8 o'clock, when the clock shows 8, now 8 p.m., the minute hand is at 12. The minute hand is at 12. When it's 9 p.m., the minute hand comes to 12 again. The minute hand, see, it's 8, it's 8:05, it's 8:10, it's 8:15, it's 8:20. So the minute hand, points to 5, 10, 15. Oh, sorry, the minute hand points to 1, 2, 3, 4, 5, 6. And when it's 9, it comes back to 12. 8 o'clock, minute hand is at 12. 9 o'clock, the minute hand has gone one round and has come back to 12. One circle every hour it makes. The minute hand makes one circle every hour. So in 24 hours, it makes 24 circles. So whatever answer into 2 will be the distance traveled in 2 days, and distance meaning 2 pi r. So for the shorthand, you can say 2 pi small r. And for the longhand, 2 pi capital R. So it's distance, children, not area. Nowhere we are going to use pi r square. Right? See the answer. You can see the answer starting right below here. Here. Shorthand, 12 hours, 1 circle. 48 hours, that is 2 days. 2 days, 4 circles. Longhand, that's the minute hand. 1 hour, 1 circle. 48 hours. Why 48 hours? Because 2 days. 48 hours, 48 circles. Children, this is 2 pi r, children. 2 pi r. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah, children. Yeah. So this is, children, 2 pi r. I've just written, instead of r, I've written length of shorthand here. It's not in brackets. 4 into 2 pi r. For r, I've written length of shorthand here. And here 2 pi capital R, length of longhand. It's not in brackets, meaning you can see the bracket here. Instead of R, I've written that length of longhand. See, the presentation can be different, but this is what it is. So I found the distance moved by their tips in 2 days separately in terms of pi, and then add both, and then use pi once for all here. Use the value of pi once for all here. Yes, this again is simple but important. Please complete the answer now in the class. So the distance covered in going 1 circle is 2 pi r. The distance covered by the tip in going 1 circle is 2 pi r. 4 circles, 4 into 2 pi r. 48 circles, 48 into 2 pi r. 1 circle is 2 pi r. 48 circles, 48 into 2 pi r. Finished, children? Yes, you should have finished by now. I've been giving you sufficient time to complete the answer in the class. Do not request for the photos. Please, if you want time, I can go back to the earlier slide. Wait for you to finish. Do not ask me to share the pictures. Okay, an elastic belt. An elastic belt is placed around the rim of a pulley of radius 5 centimeters. So pulley, you see it in a well, right? A pulley is used to draw water from the well. The rope to which the bucket is tied is put along the rim of the pulley. You would have learned it better in science. So pulley, circular. There is that depression, on which the rope runs through the pulley, right?
Yes,
so here,
yes.
yeah. So here an elastic belt is placed around the rim of a pulley. So the elastic belt is tight on the rim. It's tight on the rim of the pulley. So it's elastic, right? So it will not stick out of the pulley. It's tightly around the rim of the pulley. Okay. Okay. The radius of the pulley is 5 centimeters. One point on the belt is pulled. So see here, supposing this actually don't see this point P, children. Now just imagine you're pinching the belt here. You're pinching the belt here. You hold a portion of the belt between your thumb and forefinger. You're pinching. You pinch the belt. You're holding a part of the belt between your thumb and forefinger, and you're stretching it away from the pulley. Imagine that. You're stretching it away from the pulley. And that's how you get the elastic to the point P. You're pinching it. You pinch at some point, at this point Q, you hold a portion of the belt between your thumb and forefinger, and you pull it away from the pulley like this, and the elastic belt, it stretches like this to this point P. One point on the belt is pulled directly away from the center O. So this is center O of the pulley. So from here, from this point P, you pull the belt away from the center O of the pulley to this point P. And what is it given? The distance between the center and the point P is 10 centimeters. OP is equal to 10 centimeters. You need to find the length of the belt that is in contact with the rim of the pulley. You also have to find the area of the shaded region. I've forgotten to type that. You should also find the area of the shaded region, children. This dotted region here. You should also find the area of this dotted region. Let's read the question again. An elastic belt is placed around the rim of a pulley of radius 5 centimeters. One point on the belt, typo error, sorry. One point on the belt, not one. One point on the belt is pulled directly from the center O. See here, children, center O of the pulley until it reaches the point P. So it's pulled from this point on the circumference here. It's pulled from here to this point P, such that the distance OP is 10 centimeters. Find the length of the belt that is in contact with the rim of the pulley. So which is the length of the belt that is still in contact with the rim of the pulley? The belt here, this portion, the belt is still in contact with the rim of the pulley, this portion. Because on this portion now, the belt no longer sits on this portion. The belt no longer sits on this portion because it's been stretched out to this point P. So there is no belt sitting on this portion of the pulley. On this portion, the belt which was here on this portion of the pulley has been stretched and pulled out of the pulley like this. So which is that length which is that length of the belt that is still in contact with the rim of the pulley? This one. Here there's elastic. This is the rim of the pulley and there is elastic there here. So here this length is what you have to find. And you also have to find the area of the shaded region, the dotted region here. Yeah, please think about it. There is some typo error in this question. So let me share the question, correct question on WhatsApp with you. Though you can understand, I'll still share the question on WhatsApp. Copy the question from the picture I've shared on WhatsApp. For those who cannot see the question, I'm just reading it for you. An elastic belt is placed around the rim of a pulley of radius 5 centimeters that you see on the screen. One point on the belt is pulled directly away from the center O. That word away is missing, which makes it not clear to understand. So one point on the belt, it's not one, it's one point on the belt is pulled directly away from the center O of the pulley until it is at P, 10 centimeters from O. Find the length of the belt that is in contact with the rim of the pulley. Also find the shaded area.
Ma'am?
Yes.
Ma'am, they haven't given the figure in the question, so you have framed the figure on your own, ma'am.
Let me just check if it's given or no. No, it's not given because there's no reference number to the. There is no reference number given. But then how can it be area of the shaded region? It should be given. The figure is provided if the number is mentioned with reference to figure whatever number, but there's no mention of that. But then there's this question, find the area of the shaded region. So since we have to find the area of the shaded region, I assume that the figure must be given to you.
Okay.
Yeah, if that question was missing, fine. If it was only find the length of the belt that is in contact with the rim of the pulley, maybe you should do the figure on your own. But find the area, also find the shaded area, which suggests that the figure is to be given along with the question. Now you have to write the question and the figure, children. Let's see the answer quickly. Finished, children?
Yes, ma'am.
All right.
Yes, ma'am.
Yeah. Go through the answer.
Ma'am, can you scroll down?
Yeah, I should take you to the next page.
Ma'am, one.
All right. So how do we understand how do we start? What is that we have to find? Now we need to find the length of the arc ARB. That is the length of the belt which is still in contact with the rim of the pulley. So we need to find the length of the arc ARB. Correct? Because the belt on this portion of the pulley is still in contact with the rim of the pulley. So how do you find the length of the arc ARB? To find the length of the arc, we need two things. We need the sector angle and we need the value of the radius. We need the value of the radius. Radius we know is given in the question 5 centimeters. So what is not known? We do not know the sector angle. So without which you cannot find the length of this arc. Without which you cannot find the length of this arc. The sector angle is not known. The sector angle is not known. We know the radius, it's given 5 centimeters. We do not know the sector angle. So our first job is to find the sector angle. We need to first find the sector angle. So you can even find, if you find this angle, if you can find this angle, 360 minus this angle will give us this major sector angle, major sector angle. So now we know that OP is 10 centimeters. We know that OP is 10 centimeters. Please listen to me. We know that the radius OA is 5 centimeters. We also know that this angle OAP is 90 degrees by the theorem. OA is the radius, PA is a tangent. PA, because this line segment will touch the circle at this point A. PA acts as a tangent. PA acts as a tangent. OA is the radius. The radius and the tangent at the point of contact are perpendicular to each other. So angle OAP is equal to 90 degrees. Angle OAP is equal to 90 degrees by the theorem. Radius, tangent at the point of contact A are perpendicular to each other. This is 90 degrees. Similarly, this also a right triangle for the same reason. B, this one acts as a tangent. This is the radius. At the point of contact B, they are perpendicular to each other. That is, from the radius till the tangent, the angle is 90. See, from the radius till the tangent, angle OBP is 90. Angle OAP is 90. Now, so these two are right triangles. These two are right triangles. Now you need to find this angle. You need to find this angle AOP. You need to find this angle AOP so that you can double it and find the angle AOB. You can double AOP and find angle AOB. So how do you find angle AOP? We need to use, so this is a right triangle. We are happy because it's a right triangle. You can use trigonometry. So now this is a right triangle in which you know OA is 5 and OP is 10. So you need to connect these two sides with this angle which you have to find. See, whenever you're using a trigonometric ratio, there are three elements. To use a trigonometric ratio, first thing you should ensure that the triangle is a right triangle. First thing is it should be a right triangle. In a trigonometric ratio, there are three elements: one angle, one acute angle, and two sides. So here the two sides are OA and OP. The two sides are OA and OP. Which is the angle that we have to connect? This angle, because we're interested in finding this angle, with the help of which you can find the whole angle AOB. So let's connect this angle with 5 and 10. Now, which is the hypotenuse? This is the right angle. This is the right angle. So OP is the hypotenuse. OP is the hypotenuse because this is the right angle. This is the right angle. So OP is a hypotenuse. So for this angle, this is the opposite side and this is the adjacent side. This is not the hypotenuse. AP is not the hypotenuse, though it may look like that, you know. AP is not the hypotenuse. This is the right angle. So OP is the hypotenuse. So you need to connect this angle with this side, which is the opposite side, and this one, which is the adjacent side. Opposite and adjacent. This is the opposite side. This is the right angle. This is the right angle. And for the right angle, this is the right angle. So this is the opposite side. OP is the opposite. OP is the hypotenuse. OP is the hypotenuse. And OA is the adjacent side. Which is the side opposite to the angle AOP? Which is the side opposite to angle AOP?
AP.
Yeah, the side opposite to angle AOP is AP. Which is the side adjacent to angle AOP?
AO and OP.
No, yeah, but OP is hypotenuse. Correct. AO and OP, but OP is a hypotenuse. So OA is regarded as the adjacent side. OA is regarded as the adjacent side. Since OP is a hypotenuse, OP is a hypotenuse. So OA is regarded as the adjacent side. Now we need to connect 5 and 5, 10, these two sides which you know, with this angle AOP. So for this angle, this is the adjacent side and this is the hypotenuse. OP is the hypotenuse. You need to connect this angle with the adjacent side and the hypotenuse. Adjacent hypotenuse. Adjacent OA and hypotenuse OP for this angle AOP. Cos or secant. You can use cos or secant. So cos of angle AOP is equal to the adjacent side OA by the hypotenuse OP. So cos of angle AOP is equal to 5 by 10, which is 1 by 2. And when you find half in the cos table, cos of 60 degrees is half. Cos 60 degrees is 1 by 2. So 1 by 2 is nothing but cos 60. 1 by 2 is nothing but cos 60 because cos 60 is half. So cos of angle AOP is equal to half, which is nothing but cos 60. So on comparing both the sides, angle AOP is 60 degrees Angle AOP is 60 degrees, which means angle AOB is 120 degrees. So this is how we, with the help of trigonometry, we find the sector angle. This is how with the help of trigonometry, we find the sector angle. So since it's a right triangle, we are trying to connect this angle with the known sides 5 and 10. 10 hypotenuse, because this is the right angle, this is the hypotenuse. And for this angle, this is the adjacent side. This is the opposite side. So we are connecting this angle with its adjacent side OA and the hypotenuse OP using cos. So AOP is 60 degrees, which means AOB is 120 degrees. Now, you know the sector angle, you know the radius. Let's find the length of this arc. How do you find, what's the formula to find the length of arc ARB?
360 minus theta by 360 into 2 pi r.
Into 2 pi r, that's all. There we have to be careful. We shouldn't mess it up, pi r square into 2 pi r. So what is the major sector angle? What is the major sector angle? What is the major sector angle?
180.
What is the major sector angle?
300.
120, ma'am.
Major sector angle. Yeah, 240. Major sector angle. 240. 240. This is 120. 360 minus 120. 240. 240 is a major sector angle. Now 240 by 360 into 2 pi r will give us the length of the major arc, which answers the first question. Now, to find the area of the shaded region, children, this is a right triangle. This is a right triangle. This is also a right triangle. Now, the sum of this is a quadrilateral. OAPB is a quadrilateral. OAPB is a quadrilateral. And the area of this quadrilateral is equal to 2 times the area of this right triangle. Find the area of this right triangle and double it, you will get the area of the quadrilateral. Find the area of this right triangle and double it, you will get the area of the quadrilateral, because you have the same triangle here. The same thing here. So find the area of this right triangle, double it, you will get the area of the quadrilateral OAPB. Now from the area of the quadrilateral, take away the area of this sector, the minor sector. From the area of the quadrilateral, take away the area of this minor sector, whose sector angle is 120 degrees, to get the area of the shaded region. You can do it in more than one way, children. See, this is one way. See, you can do it like this also. You can find the area of this triangle, children. You can find the area of this triangle. Then take away the area of this sector, whose sector angle is 60 degrees. Whose sector angle is 60 degrees. You can take away the area of this sector, whose sector angle is 60 degrees, to get the area of this shaded region. Double that answer to get the area of the entire shaded region. That way, that is one way. Otherwise, you can find the area of the quadrilateral and then subtract the area of the sector with sector angle 120 degrees to get directly the area of the entire shaded region. The choice is yours. Area of the length of arc we understood. You can see it here, theta by 360. 360 minus theta by 360 into 2 pi r. Length of arc. This answer alone I'll share. Since it's time, let's just see the answer. I'll share this answer alone. I want all of you to stay back. Don't leave the class. Now, announce your names before you leave. Announce your name before you leave.
Shivani.
No, darling, we haven't finished the session. Once I finish the session, please announce your names before you leave. So now,
Ma'am, can you send that elastic belt some also, ma'am?
yeah, that's what I'll share. Yeah, I'll be sharing.
Thank you, ma'am.
Yeah. So the area of the right triangle, half base into height. You can again use trigonometry to find the unknown side. You can use trigonometry to find the unknown side. You can see it here, it's worked here. To find the unknown side, you can use trigonometry here to find AP. Half base into height will give you the area of the right triangle. Area of the right triangle, half base into height. I found it here. Area of the sector. As I explained in the second case, you can find the area of the sector AOQ, whose sector angle is 60 degrees. Find the area of the shaded region and double it to find the area of the entire shaded region. This is the second method which I said. With respect to this, so what you see there is, I found the area of this triangle AOP, half base into height, base AO, height AP, not OP, children. OP is the hypotenuse. OP is the hypotenuse. This is the right angle. This is the right angle. Half base. You can take AP as the base, AO as the height, or AO as the base and AP as the height. This is the right angle. This is the right angle, half base into height, but we don't know AP. So you can find it using, you can use Pythagoras theorem also. You can also use Pythagoras theorem to find AP, or you can use trigonometry and find AP, the length of AP. So half base into height will give you the area of this right triangle minus the area of this sector, 60 degrees. Sector angle 60 degrees will give you the area of this shaded region. Double that answer to get the area of the entire shaded region. So that's it for today's session. Use the emoji, raise your hands. Class, use the emoji, raise your hands. That's good. Good to see you all here till the end of the session. All right, children, thank you so much. You may leave the meeting. If you have any questions, stay back. Yeah, thank you, children. Announce your name. Srinivasan.
Reshmika ma'am.
Hirunesh ma'am.
Shivani ma'am.
All right.
Priya ma'am.
Anish